Hi everyone, thank you. Okay, so I'll just be I appreciate that I'm in a crowd full of Aki and Yilgarn Craton workers, so I'll give a little bit of a background on the Perth Basin and its tectonic development. Then I'll go into how the seismic interpretation was constrained, and I'll go through each line and show you the actual interpretation against the seismic. And then it's really interesting to see these three lines compared against each other. I also thought I'll include some nice pretty pictures of the actual acquisition here. Here we've got the western end of line Southwest 1. So a lot of you are probably familiar with this scene. It's near Hamlin Bay. And here we've got the road leading east from Geraldton. So as you can imagine, there's a lot of tourists who'll be using this road, a lot of traffic on these highways. So to try to minimise the amount of noise, so acoustic noise, some of the acquisition took part at night time. And that helped quite a bit. Here are the three lines all centred along the Darling Fault. And hopefully, yes, that's there. This dotted blue line is the base of the Perth Basin. And immediately we can see how different the rates of subsidence were across the three lines. On the right here, we have the grav image, and at least in the onshore part of the basin, the grav is a good proxy for the depth to the basement. And we can see where we have that gravity, nice big gravity low against the Darling Fault here, and centred where MW2 is, that corresponds with a nice deep basement here. Another really obvious thing you might see from these three lines is that we have really good reflectivity of the lower to mid crust in the cratons, but as soon as you go under the basin, that reflectivity, it goes. I guess the main reason for that would be that we have this basin here and its layers across which there's a high velocity contrast. That's what gives us these reflections. So it's just difficult for that acoustic energy to penetrate deep below the basin. But also the Perth Basin, you can see here, this is oceanic crust. So the Perth Basin was a successful rift basin. It led breakup occurred, final breakup and seafloor spreading occurred in the Cretaceous, early Cretaceous, to give us this Indian Ocean crust. And this distance here from craton margin to oceanic crust here at its thinnest is only like 180 K. So you can imagine you've gone from thick cratonic lithosphere to basically where the lithosphere has ruptured in a relatively short distance. So you can imagine how much modification of the lower crust there has been under the Perth Basin, especially in this part. So that could be another reason why you've just got obliteration of any reflectivity down there, just because of all that Phanerozoic modification and all that, heat injection. As well as, whatever happened in the Proterozoic during the Pinjarra origin. Right, so as Ivan and Raf and Tim mentioned, the Perth Basin is underlain by the Pinjarra origin, and we have them exposed here in a few inliers. And also there are some penetrations within some petroleum wells in the Perth Basin, and work is still underway on studying those. We know from the inliers that are exposed that each of these terrains, the thermotectonic history is seemingly unique. So, we have high-grade rocks in these inliers, but here where we have these, the Yandanuka and Moora Basin, it's very low-grade metamorphism. I think they're like green schist facies or something. So it's a very interesting heterogeneous basement to the Perth Basin, and it's long been recognised that the structures of the Perth Basin and the faults that separate all the sub-basins, so they're predominantly north striking. It's long been recognised that these are probably reactivated structures from the Pinjarra origin. And the question has always been, given we see such differences in the amount of subsidence along the basin axis, to what extent did these different Pinjarra origin terrains affect the development of the Perth Basin? And you'd expect perhaps where there's a part of Pinjarra origin that is, rheologically weak, that would stretch more during the Phanerozoic rifting and create more accommodation space and more subsidence in the Perth Basin above. And I think some of the results of the passive seismic that Klaus will show and others will show really show how there really is under the Perth Basin a heterogeneous character. So again, probably controlling the rates of subsidence in the Perth Basin. So this is just a cartoon showing the tectonic reconstruction of Australia during Gondwana rifting time. Perth Basin is about here. So most of the basin fill is Permian to early Cretaceous. So again, I mentioned early Cretaceous is when we finally had our breakup and seafloor spreading. There are some older rocks that we see. So Ordovician to Carboniferous rocks we see in only MW1, so that northern line. But for the most part, most of the rocks are Permian to early Cretaceous. The conjugate margin to the Perth Basin at this time is this landmass here, that's Greater India. It's postulated to now be smashed up under the Himalayas and Tibet. The Perth Basin is a mature petroleum exploration and extraction province. And on the right here, all these purple lines are the existing 2D industry seismic lines. So I haven't included in this picture all the petroleum wells that there are as well, and there's still discoveries being made in the Perth Basin of gas. So there's a lot of industry data that can help constrain this interpretation, which is good because there's not a lot of outcrop of Perth Basin rocks. It's also a bit of a curse because your interpretation has to tie in with all of that seismic as well. But at least we have a lot of constraints. There's still a lot of challenges, which is normal for seismic interpretation projects. So there's some poor signal penetration in some areas, and we can see that in some of the lines. It can be really difficult to pick the top of the basement, and where faults are subparallel to lines, it can be really, really tricky to pick. So that's why having this network of existing industry seismic lines really helps to constrain the strike of these faults. And on the right here, I don't expect you to read all of this, but each of these lines are the tops and bases of the formations that were picked, just to really show the history of the basin fill. All right, so starting with line MW1 in the north, we can see the geometry of the Perth Basin here is essentially two half grabens against the Darling and the Urella faults. So the Urella fault is one of the major splays off the Darling fault. I should also mention that all of these lines have really strong vertical exaggeration. It's common in basin world to really make that vertically exaggerated just because the dips are so low. To see anything subtle, any changes, you really have to stretch it out. But we can see here also these steeply dipping reflectors, as Tim pointed out in his talk. These steeply dipping reflectors under the Perth Basin basement is probably related to the northern extension of the Yandanuka Basin. We don't know. It would be nice to drill it to find out, but Certainly we've got some outcrop up here. It's not shown here. This is just a simplified outcrop map of some steeply dipping Proterozoic sediments and lava flows that correlates well with these reflectors. Heading further south in MW2, again we can see the influence of the Darling and Urella faults, but here we can see that the Urella fault has actually become the major fault controlling subsidence here. Sorry, it's a bit hard to see. Obviously, the interpretation here is very tentative. I don't have any drill holes that go down to 12 kilometres deep, unfortunately. But the basement here could actually be a little bit deeper. As you can imagine, at the base of basins, especially at 12 kilometres deep, it's very cooked up, metamorphosed, so there's not likely to be a strong velocity contrast between the basement and the basin. So I suspect this could even be deeper, to be honest. Between the Urella and Darling faults, again, we've got this package here. I just wanted to draw attention to this one because I've tentatively called it Perth Basin, but there's a very good chance that it's actually the Yandanuka Basin, and we were really hoping to see the Yandanuka Basin in these lines because the Yandanuka Basin it outcrops just a little bit further north of this line, and you can see this mag anomaly in the first vertical derivative, and this can be traced up to where the Yandanuka Basin outcrops. So we don't really know what it is, but it would suggest that there is Yandanuka Basin at least somewhere here, but where it is exactly we just don't know. Why these lines were really valuable is, in addition to all the deep crustal stuff that we can see, but despite the fact that we have lots of industry seismic, a lot of that industry seismic was acquired in the 60s and 70s when they were still using dynamite, and the quality is really poor. So I've highlighted here how much this line has improved the imaging in certain parts of the basin. So here is an industry line from, I think it was the 70s actually. And you can still see the broad structure of this particular fold, but we can just see so much more in the new seismic. We can see thickening of this package, for example. This is a Jurassic package against this fault. So it's just giving us constraints on the timing on some of these structures. Heading further south now, looking at line SW1, again, this is showing the importance of the Darling fault in controlling the sedimentation. We can see this pronounced thickening, like in line MW2, we see this pronounced thickening of this package here, this Mesozoic package. So the Mesozoic was the last rifting event that led to breakup. So we'd expect to see nice thick packages thickening into the major faults. We can also see some interesting reflections below the basement here, and we've correlated that to the Lewin inlay. We can see some nice layering here, which I think is consistent with the gneissic fabrics we see there. And you might be tempted to call all of this basin, but we do have a drill hole that is not far north from this line. It intersected the basement, and it gives us a bit of a constraint on how thick some of these packages should be. So it can be tricky when you're dealing with basement terrains that are metasediments. Sometimes they look like the basin above. So if it weren't for a lot of these petroleum drill holes, it really would be tricky to pick some of these horizons. All right, so I've just comparing the three lines here, and I've coloured it up according to age and major rifting episode. So the yellowy colours, so this is that older package that we only see in the northern line. so line MW1. And it's really better to consider this package to be an extension of the sedimentation in the Carnarvon Basin, which is further north. So the Carnarvon Basin is a much older basin and contains much thicker Ordovician to Middle Carboniferous rocks. I consider the true Perth Basin to be the Permian and onwards rift basin. So we can see again a very distinct difference in the thickness of that Permian package. So it's present, it's very thin here, but it is present. It's present across all three lines, but it really is thickest in the southern part of the basin. So again, it's showing us that at different times, the locus of sedimentation and subsidence changes as rifting progresses and the depicenters shift. Because as rifting continues and we head into the Triassic and into the Jurassic, we can see, well, rifting has almost completely ceased, or extension has completely ceased in MW1, and now the rifting is focused in the southern two lines. And especially in MW2 in the centre here, that's where we've really got the thickening of this big Jurassic package. So this is only a period of about, this entire green package is a period of only about 50 million years, and you can just see how much subsidence there's been here, in excess of 8 kilometres. So it's really this centre part of the basin that's experienced a lot of stretching and subsidence, and that's why we have this big gravity low here. So just to wrap it all up, the new lines really have helped image some of the complex structures in the basin, and they demonstrate that the depicenters within the basin have shifted over time as rifting progressed. And they also show that there are thick Proterozoic basin successions under the Perth Basin, and you've seen it in some of the other talks, but the forward gravity and mag modelling will really help refine our interpretation, and we've seen some preliminary results so far. And if there are new petroleum wells or new seismic lines, we'll always refine our interpretation. And that's it. Thank you.